Number two, chemical equilibrium. Okay, what's this? I need to. This is chemical engineering board examination. What's this? 1987. Oh my gosh. 1987 daw. Oh my gosh. Okay. Ano nangyari? Okay, 1987 board examination problem. This one? Ah, okay. Okay. Ganon. Ako isuwat guys sa mo na siya. November Chemical Engineering Board Examination 1987. Okay, at a certain temperature, ammonia partially decomposes into nitrogen and hydrogen gas. Ammonia was added, ay nakakaloka, to an empty container until the partial pressure of NH3. Actually guys, there's an answer. All you have to do is to, if you're correct, then your solution will be correct also. Okay, like that. Okay. And then ammonia was added, okay, until the partial pressure of ammonia reached to 25 atmosphere. At equilibrium, the partial pressure of H2 was found to be 0.45 atmosphere. What is the partial pressure of ammonia at equilibrium? Muna siya nakakaloka ng mga problem, guys, because to be honest with you guys, partial pressure at this topic before, 20 years plus ago, in my chemical engineering, as far as I could remember, if we touch chemical equilibrium topic and phase equilibria, expression of concentrations topic under chemical equilibrium, we don't normally attach pressures in the examples. Okay, but sad to say, we can relate pala talaga pressures then for that. Okay, so it's been said based on my research that the pressure will be directly proportional to the concentration. That's why we need also to attach the same thing in the concentration, chuba chuchu. Chuba chuchu means matters or any matter. Okay. Chuba chuchu, blah blah blah, like that. That's chuba chuchu, blah blah blah. Okay, like that. Now, for example, guys, if I will have the, nasa to nakalimot man ko. Okay, if we have the, mawala. Okay, then pasa. Okay, okay. Okay. Let me think for a while. Nakalimot ko sa theory. Okay, I think this is, law of mass action. Okay, it's still in my brain cells. Oh my gosh! Law of mass action. Okay, lain sabi siya guys ha, di na siya palihog. This is not the same to the law of conservation of mass. This is really law of mass action. Okay, this is different. For example guys, if you have A plus B, this is hypothetical, is equals to reversible reaction. O diba? Ganon. Okay, then C plus D. Okay, two reactants will produce two products. And now we have your coefficient as, for example, lang siya guys ha, H, I, L, N. So your expression will be in the law of mass action will be equilibrium constant of the expression in law mass action is equals to the concentration of C raised to the power small letter L times the concentration of D. Makita ko niyo guys. Okay. Nalagyan siya mo yung tagsa-tagsaon guys. Okay. And then the concentration of the D raised to the power small letter N and the concentration of A raised to the power H and the concentration of B raised to the power I. Ganon. So this is equilibrium constant. But we can also say in another way around if attaching the partial pressure. Okay, something like, let's prove this first before anything else. Why? Because there's a lot of quantities. Why pressure dyan ang dipili? Something like that. Okay, there's also volume, number of moles. Okay, we have also the temperature. Then why pressure dyan ang dipili? So let's go back to PV and RT. Okay, PV and RT. How can you compute concentrations in this PV and RT? Then you have to derive, right? How can I do this? Okay, derive. So you can say concentration it's gonna be, wait for a while guys ha. Okay, concentration is equals to moles per liter, meaning to say M over V in this PV in RT chuba chuchu. So we can say pressure times V is equals to, okay, the concentration, no wait, no, concentration times volume because it's N. If you compute N in this equation, we can say number of moles equals to concentration times volume. So substitute that here, it will become P times V, so concentration times volume times R times P. So in this equation, volume is cancelable. Volume. So what will remain? Pressure is equals to CRT. And this is also an equation used in the colligative property in the computation of osmotic pressure in the semi-permeable membrane of the reverse osmosis topic. You get the point if you remember that one? The vapor pressure lowering, the boiling point elevation, the osmotic pressure, freezing point elevation, ganon. So osmotic pressure is equals to CRT. Ganon, di ba? Pressure. P is equals to RT. Muna siya yung gamit sa osmotic pressure because of that PV and RT chuba-chuba. Okay, going back, the same thing here. So pressure is equals to CRT. Now, in our chemical equilibrium, guys, we are using the concentration. Now, try to equate the concentration in the relationship of this P is equal to CRT. Okay, the basis for that is we need to determine the relationship, the proportionality, inversely proportional or directly proportional. Now, if it is directly proportional, we can simply do the same in this manner. If it is inversely, it will not be used. Okay? So, compute for the concentration. Concentration is equal to pressure over RT. Concentration is directly proportional to the pressure. So, therefore, we can conclude if concentration will increase, the pressure also will increase. If the concentration will decrease, the pressure also will decrease. So we can also say this is partial pressure of C raised to the power 2 because it means the same thing at chemical equilibrium, their physical property. Okay, like that, or its property. Take note, concentration is not physical property, sorry. It is chemical property. Okay, the pressure is physical property. Okay, like that. So, partial pressure of C raised to the power 2. And then partial pressure of D, this is L. So L pala niya siya, L, not 2. So partial pressure of D raised to the power M. And then partial pressure of A raised to the power H. And partial pressure of B raised to the power I. Okay, so the same thing. Okay, now if you are in this topic now in your classroom instruction, expand your knowledge because more or less the teacher will not give an example about pressure. But in the examination in the prelim and midterm, he or she will include that in her or his examination for sure. Okay, like that. So unhin na lang daan. Okay, this is gonna be the situation. Okay, because you cannot equate here the number of moles here. Okay, you cannot equate here the volume. Pressure yun siyang ini-equate niya ang higayon na. Okay, so i-memorize na namin siya guys na pressure is equals to concentration times universal gas constant times T because this is also one type of formula that we can compute directly the pressure if you have given the concentration. For example, if the question is very easy, like that, for example, an ideal gas ammonia, ganon, has a concentration of 2 moles per liter. What's the pressure? Imagine, there's no other given, but you can compute for the pressure. Meaning, this ammonia behaves ideal gas at STP. Na naman kayo mga standard at STP sa ammonia, RT. Nagsagay concentration, bingo, you can solve for the pressure. Even though wag i-mention ang STP nga word. Okay? But ideal ammonia man. Okay? Ideal, if you say ideal, it corresponds to a standard temperature pressure, not necessarily dimensions of question. You get the point? Or other way around, dimension ng STP, wala gibutang ang ideal na word. You get the point? Gibitik taana muna siya. Okay? You get the point? Or ano siya pagsulti? An ideal ammonia has a concentration of 2 moles per liter at a compressibility factor of 1. How much is the pressure? Patay. Nagsigot na siya compressibility factor. Now, in theory, if the compressibility factor is 1, that is behaving as an ideal gas. So, use STP. Things like this normally comes in the board examination. And then you cannot expect that to happen every time. That's why you need to memorize basic foundation of the standards and correlate all formulas. Link that so that you can create your own formula and equation. Nakakaloka. Especially in the third day, like chemical engineering, you will be forced to make your own formula and equations because makaingo ba maragwa itudlo. Okay, but sige lang, ipon-ipon mo siya until such time you can make your own formula and equation to solve the what is being required. But dili tanan ha. Okay, I think it's gonna be 5 lang or 4 lang ganun. Okay, but actually makuha rin din na nimo pero maglibog na mo gagod kay time frame ba? Time frame then pressure. It's gonna be like that. So it's gonna be like marong jud ta. Oh, di ba? Oh, sinita po. Okay. Now P is equals to CRT. Now, natin question na regarding sa pressure. Muna itong gamitin ng example. Kasi mga talangga ha. Okay, go. Ganon. Ay nako. Magkakaloka. At a certain temperature, ako na rin papasok mga talangga. Okay? Ana ara. Importante din siya guys. This is very important in studying chemical kinetics or chemical reaction engineering branch of science that deals with the study of how fast the chemical reaction really is. How fast and slow the chemical reaction really is. I mean to say, dependent on time. Because how can you say it is fast? How can you say it is slow? Of course, you will take down the time. Okay? That's the point. It has to do something with motion. Okay, motion. And then equivalent kinetic energy. And then, of course, activation energy. You have to activate your energy so that you can produce motion. Okay, there's no motion if your energy will not be activated in the first place. Right? You get the point? Go back to the problem. Okay, mga palangga. Nakakano kasi June. Okay. Ako na lang ibutang, isuwat na ko guys ha, at a certain chuba-chuchu. Nakakaloka. Okay, problem number 2. At a certain, ganon, okay. At a certain temperature, ganon chuba-chuchu. Okay, ammonia. Okay. Guys, you know, even though I am already here, you know, the brain is still, I have to share to you this. This still have reached me if I will be, you know, one of the instructors of their chemistry. Because actually before going here, I was offered by Bahrain to teach chemistry. Okay, but I never pushed through because at that time, they don't process immediately. Okay, siguro to ako dito lang teach of chemistry. Wow. Okay, but you know, I choose this because a little bit faster in the processing, something like that. Okay, and there's also a little bit difference also with the offer. Okay, get the point. But I like Bahrain. Sige na lang. Okay, in the future. Okay, so it's gonna be like that. One of the universities of Bahrain. Okay? Nako, nakakaloka. Okay. Partially. Okay. Gano'n na siya, chuba-chucho. Okay. Decomposes. Okay. Decomposes into nitrogen. Because I did not expect that they will call me before because I don't have experience in actual teaching. Really. I'm not taking up BS education major in chemistry or like that, whatever. Okay, but I still have to pursue. But they know also that I'm a licensed chemical engineer, of course, because I've submitted all my credentials to them. Maybe they give me a chance. Charot lang. Okay. Ako pa dyan i-share, ngunit nakakaloka. Okay, that's too personal to share, right? Nitrogen gas. Okay, and hydrogen gas. Okay, ganon. Okay. Kung ano pa dahil mag teaching guys. I love really teaching. Charot! Okay. Ammonia was added. Okay. Nakakaluka. But I found out also if you keep on talking, your voice will get affected, right? Really. Okay, when I sing, I get easily tired also when I sing. But if I don't vlog, okay, I can sing very well and my voice is really stretching to the highest levels. But if I keep on talking, guys, I cannot sing too much. Really, 4 songs lang, 3 songs lang, ganun. It will really affect. Dito gingon sa akong nephew, who is also a public school teacher, that every time they will use their voice, and then their voice will be cracked, will be strained, something like, oh my gosh, I don't want that to happen to me. Because I love singing that much. Okay? I love singing more than teaching. Of course, nakakaloka. Suffer ako laing talent. Nakakaloka. Ay nako, ammonia. Napansin nyo na natin guys, yung si Yaw-Yaw, wala ay namin kuhan. Tutunlan. Nakakaloka. Okay, hydrogen gas. Muna'y gamble dyan siya guys, no? If you are in the academic profession. At equilibrium, okay, gas. Ammonia was added. Okay, was added. No, okay, kaloka. Was added. So siya was added to an empty chuba-chuchu. Ito an empty container mga palangga. Okay, until the pressure ganon. Until the partial pressure, nakakaloka. Okay? Partial pressure of ammonia reach. I will explain also why the term partial pressure is expressed, not the vapor pressure or atmospheric pressure. I must explain why later. Reach, okay. Okay, reach 2.85 atmosphere. Okay, ganon. And then, at equilibrium, haba naman. At equilibrium, ano nangyari? At equilibrium, nakakaloka. The partial pressure, ang haba ng problem na ito. Partial pressure of H2, ay nakakaloka, of H2 is 4.5. So, 4.5 atmosphere. Diba? And then, kasi gumawa ito ng higay yun na. Okay? What is the partial pressure of ammonia? Ay, nakakaluka. What is the partial pressure of ammonia? Wala. Partial pressure of ammonia. Nakaloka. Ammonia at equilibrium. Okay? Klaro kaya na i-word na equilibrium. Okay? Then, agad na dito sa problem. Okay, ganon. Okay guys, why this is called partial pressure? Anybody can explain why? Because there's a lot types of pressure. Atmospheric pressure, okay, absolute pressure, gauge pressure, operating pressure, okay. We have also dynamic pressure, hydraulic pressure. What else? A lot. The absolute pressure, diba? And then vacuum pressure. And there is also vapor pressure, total pressure. And now we have also partial pressure. Why partial pressure is the term used to attach to this particular topic, not only the pressure regular. What I mean by pressure regular, there's no adjective describing the type of pressure. Meaning understood, it could be either of what I'm mentioning right now. Okay, so mass regular, volume regular, because there's a lot in chemistry. You should be specific what type of quantity is that, because there's a lot. So, molar volume, molar mass, molar enthalpy. Then I will say regular. That means there's no adjective describing that kind of quantity. Okay, for example, entropy only. Because there's also molar entropy, molar density. And then if you attach the word molar describing that kind of quantity, the formula will change. You get the point? The same thing also here. Partial pressure. Do you think that the pressure formula will change because I attach partial? Okay? Meaning, this is a pressure that is referring to partial. Meaning to say, the individuality of the pressure of each element and component. Individuality. Inherent pressure. Meaning pressure sa iyong kaugalingon. Okay, something like that. Okay, that is partial pressure. Individual pressure. Okay, because if you don't put partial, it is vague. Vague, V-A-G-U-E, meaning confusing or not specific. You get the point? So you always put partial pressure. As you can notice that in chemistry books or physics books or physical chemistry books, there are always partial attached to it. Not only pressure, especially at this topic. Okay? You get the point? Okay? In the PV and RT, there's no question because pressure is just pressure there. Okay, and then it's very clear that it's dealing with standard at STT or whatever in ideality. But in here, you should mention the partial, okay? Like that. And then if it is also mentioned the type of pressure, ayaw pugsa. Okay, and then you have to take note. Ang sa formula of absolute pressure? O ganan. Di ba na yung mga formula? Total pressure is equal to absolute pressure plus the vacuum pressure below the sea level. Ganan. O di ba? So, equals na to siya or katong PSA man na siya kung absolute. Okay, di mag-add kag 14.7, ganun. Kinam sa term na PSIA. At wala siya kasagaran sa thermodynamics, physical chemistry, ganun. Na siya PSA, meaning absolutely siya. This is not the PSI alone. You get the point? So something like that. So you need to be extra careful for the description of the quantity. Okay, descriptive. Title of the kind of quantity. So in this case, partial pressure. Ganon. So this is also derived from Dalton's law, ha? Katuloy mo siya nga. Total pressure will be equal to the individual partial pressure of the elemental constituents in one compound. Something like that. For example, if I have calcium carbonate and it will decompose into carbon dioxide, blah blah blah, so and so, diba, into calcium carbonate into carbon, something like that. Okay? So, or calcium oxide, let me see. Calcium carbonate, ganun chuba-chuba-chuba, diba? It will decompose into carbonate plus CO2. Okay? Like that. I cannot say by telling, I can say if I will write. Okay? You get the point? Mamana siya, no? So, the pressure of carbon dioxide, the pressure of the carbonate, gano'n, ibungkag-bungkag mo siya. So, muna siya kitawag ang partial pressure of each elemental constituent. Wow, constituents. Okay? Yes. Muna siya nitawag. Okay? Muna siya yung reason why partial pressure ng butang perdi. Okay. What is the partial pressure of ammonia at equilibrium? See? Partial pressure perdi, no? Hindi siya pressure regular. You get the point? So yung aling nga problem, guys, makadetect dito na, murang sa chemical equilibrium yun siya, anak na yun. Especially na yung mga word na equilibrium, mo sa mga teknik-teknik may solve a problem, ha? Kung na yung mga term na ni Ana, mo siya timanan. You get the point? Even though, lalo na sa inyong high school or first year, di mo siya kalimutan, nagkabot mo 4th year college, 5th year college, so it will be attached there. They correlate. Something like that, connecting the dots, just like politics. You have to connect the dots in the past or the history, or something like that. You get the point? Ano siya? Now, kung saan lang ito pag walang higal yun na, ammonia na yun. Given, ganun. Nakakaloka. So, container, pressure of ammonia, which partial pressure of ammonia is 0.85 atmosphere. 0.85 atmosphere siya mga talangga. Okay? 0.85. Now, by English, we can understand also that initial and partial will be just the same. Okay? You get the point? For example, this is the partial result. You will also say, this is an initial result, meaning the same meaning. Okay? Or temporary result, not final. Okay, if you say final, that's not initial, temporary, and partial anymore. So that's why this partial pressure mentioned here is also the initial pressure of the, what's this? Partial pressure, ammonia. Okay? So I could put PI, means partial pressure of ammonia, right? Like that. Okay, and now, what is the partial pressure of ammonia at equilibrium? So, asking now in the equilibrium. Okay, so we need to say P, EQ, at equilibrium. Ganon. Get the point? Oh, so mali siya ng tabo na nangagayon na. Okay. And then, take note guys, mga palangga, we don't have any given. Only one. Imagine the paragraph is very long. Okay? Then it requires analysis. Because see, only one given. And this is made difficult. Okay, like this. So there's no Superman in computations or calculations, especially pure sciences. Okay, like that. So, more dito yung given, 55. Okay, like that. Now, since your topic is chemical equilibrium, okay, ganda ng chupa-chucho, okay. This is under, ano guys ha, changes of matter, because these are all chemical change. If you try to react one element over the other element to the compound, this is a chemical change. It is number one. Number two, this is under also classification of matter, under mixture. Because you mix hydrogen gas, nitrogen gas to produce ammonia. Okay, it's a mixture. So if you try to look back the flow chart of chemistry, it's still there. Okay, in the flow chart. What we are studying right now, or what we are discussing right now. So that we can say, where are we now? Something like that. Okay? So this is chemical equilibrium. Ganon. Okay. It has to do something with a mixture. Okay? So, ganon. So, chemical equilibrium na ammonia. So, niingon siya ang problem, guys, na ammonia, di ba? So, meaning to say, nidecompose siya. Okay? Nakakaloka. Okay. So, niingon siya, guys, na mauna siya may tabo. So, ammonia. Okay? Ganon. Then, turn to N2 plus H2. Ganon. So, balance the chemical reaction. 2, 6, 3. This is equation 1. Okay. Notice, guys, this is reversible chemical reaction or irreversible. Reversible or spontaneous because it will go back to its original form later on. So, we need to put the arrow something like this. Reversible chemical reaction. Ganon. If you see a chemical reaction that have two arrows going to the right first, and then after and the top going to the reactant, that is reversible chemical reaction or spontaneous chemical reaction. Okay? Being by nature, it will go back to its original form without any additional, processes involved. Natural. Okay? Like that. Now, let's say we apply now the chemical equilibrium because this is already balanced. Still the same, guys, the procedure balance first. Okay? Just like before. Okay, so concentration of N2 raised to the power 1. Okay, concentration of hydrogen gas raised to the power 3. Over the concentration of ammonia raised to the power 2. Oh, this is also pressure, right? This I told you earlier. So partial pressure of N2 raised to the power 1, partial pressure of H2 raised to the power 3, and partial pressure of ammonia raised to the power 2. Okay. Lingon siya at equilibrium. Okay, at equilibrium, calculate the partial pressure of ammonia. Okay, ganon. So, natay makuha nimo ang partial pressure of ammonia at equilibrium. So, kanigi-pangita ang denominator. Okay. So, we will also use this NH as our partial pressure. This one. Okay, or initial pressure. Now, we go back to the ice. Nakakaloka. Di ba ice? Muna may tabo. Okay? So, ice. I-C-E-O. Initial sa ammonia, pila. Dapat siya pressure naman naghihata, di ba wala? Ay okay, sorry. 0.85. Right? So, 0.85 ang pressure. 0.85. Oh, ganon. Ang nitrogen, ano siya pressure yata? Wala. 0. Okay, ang hydrogen, wala sa 0. Okay, at concentration, at pressure changes. Because this is not dealing with concentration. Ano rin siya guys? IPE. Because this is pressure, not concentration. Okay, sige lang. For the purpose of discussion. Okay, so ganun siya. So it's gonna be, if your pressure will also decrease, the same thing with concentration. So it's gonna be, since this is 2 moles of ammonia, it's gonna be minus 2x. We let x as the pressure of ammonia at equilibrium. Okay, the same thing with N2 and H2, this will become x. Okay, and also H2, this is 3x. Because there's 3 in the coefficient times x, and N2 there's no coefficient, that's why x lang yun siya. And at equilibrium, ano yun siya? 0.85 minus 2x. Because this is 0.85 plus minus 2x. It will just equal to 0.85 minus 2x. Math. Okay, so 0 plus x is just equals to x. 0 plus 3x is just equals to 3x. Now, substitute this value here in the equilibrium by using partial pressure. Okay, partial pressure of nitrogen pila siya. X lang yun siya. Okay, but you have an initial pressure of 0.85 chu. Ganon. So you can compute for the pressure for this. Nakakaloka. Okay, ako na naman gipapas ang problem. Okay. Kung ano niya guys, no, masolve din mo siya. Naglubat man ko guys, ano ko ma-retrieve. May wala ko ipapas, no? Okay, so in this case, your requirement will be you have an equilibrium constant given. Ako mag-ipapas ang problem, wala ko memorize. Okay, and then we have the ammonia here, pressure, ammonia pangita. Okay, and you have the pressure of N2, H2 like that. Since you have 0.85, can 25 minus 2x, then nakaka-equilibrium given, so masolve mo ang x. So kanina mga x, chuba, these are all the partial pressures. Makuha rin mo siya because all are x. There's no other variable. Right? By solving through algebraic expression in math. Okay, so 25 minus 2x, x, 3x, substitute that here, and you can solve for the value of x because you know the value of the equilibrium constant. Okay, but if you don't have equilibrium constant, you cannot solve. Okay, unless the x also will be given somewhere in the equilibrium. But in here, he said, calculate the partial pressure of ammonia at equilibrium and siya. So for sure, there's no value of partial pressure at equilibrium. So it's gonna be given to ang equilibrium constant, wala yun ako masuwat. Nakakaloka. Okay? You get the point? Oh, ganun siya. So ito pa guys, it's very easy to solve if there is an equilibrium constant. Now, if there's no equilibrium constant guys, it could either be, it will be given in the equilibrium pressures, makuha nimo ang equilibrium constant. But in here, wala siya. It's impossible kasi na 2 or 3 unknowns niya usara ka equation. Because in math, if there are 2 unknowns, at least you have 2 formulas to be used also. Okay? So, mo man na siya. Kung saan na siya nga law, nga naman na siya nga law. This is the law of degrees of freedom. So, degrees of freedom law in science and mathematics, meaning to say, if there are 2 unknowns, at least you must have 2 formulas and equations to be used. Something like that. Because if you have 3 unknowns and your formulas and equations are lesser, you cannot solve what is being asked. Okay, unless there is a standard attached into it in the paragraph or standard that you are trying to use that in your memorization. Na constant yun siya guys, sa itong mga, for example, mga Planck constant, Boltzmann constant, ganon. O diba? And we have also the Avogadro law constant, ganon. So, even though there's only one given, then you can attach the standard. Okay? Muna siya ang law of the degrees of freedom. Something like that. Okay? So, muna igot pasabot. Oh. Any questions so far? So naman siya guys, diba? Okay? Like that. Okay, you can comment down below and share it to anybody else and you can subscribe to my channel. Okay, bye-bye. God bless everybody. Okay, manadyo ko. Okay, manadyo ko. Oh, nakakaloka. O, di ba? Bye-bye. Oh,